All right, so this is our last lesson, probably actually our easiest lesson of the three. And so we're going to just kind of jump right into it. And we're going to be talking about composite figures. So composite figures are basically just when we have kind of a more complex figure that we can break it up into more individual shapes. So we don't really name these shapes all the time. I mean, technically this has 1, 2, 3, 4, 5, 6 sides. So technically this would be a hexagon, but hexagon, but we don't really think of it as a hexagon. We just kind of look at it as a composite shape. So we're going to find the area of this. What you're going to want to do is just kind of see, oh, if we make a line right here, that turns that guy into a triangle. If we make a line right here, that turns that guy into a triangle. So we have one triangle, a second big rectangle, and a third triangle. Now, some people break it up even more. Some people might be like, oh, I have two rectangles and do it that way. That's fine too. I don't really care what way you do it, as long as you break it up into shapes that you can find. So right now, we're going to break everything up into triangles and rectangles. For perimeter, we do the same thing. We add up all our sides. Now, you do want to be careful about any diagonal lines, right? We will have to do a squared plus b squared equals c squared to find that distance, but otherwise we're just adding up all of our outside edges. So let's kind of jump into it and just try that. So for the area, for the area, we're going to first split it. So like I said, I'm going to split this into 1, 2, and 3. So I'm going to do the area of my first shape. Now, we do need to do a little bit of math here. You can see that, if this distance was 10, and we know these two triangles are equal from that line. So 20 minus 10 is 10. That means that the remaining distance is 10. So that'd have to be 5 and 5. So we had to do a little bit of math, kind of thinking, right? This entire length was 20. The middle part was 10. So that means we need 5 and 5 there. Yeah, we'll also have to do some math here. This upper part is 6. The whole line is 18. So this guy is 12. Okay, so the area of shape 1, that's the base and the height, is 1/2 times 5 times 12. Cross cancel that. 6 times 5 is 30. For the middle section, okay, this base is 10, and the overall height is 18. So just base times height, 10 times 18. And we'll get 180. And for area 3, you don't really have to redo it if it's the same shape. So we get another 30. So then the area of our entire shape will be 30 plus 180 plus 30. And that will be 240. And this is where we'll want to put the unit squared at the end. All right. Then for perimeter, I'm going to do a different color for perimeter. I'm not going to do blue though, because it's already in blue. That would not work out too well. So for a perimeter, we're going to add everything up. So we know that this guy's 20. Plus, now when we get to this guy, we don't know what it is. So I'm going to put a c there. So we're going to just have to kind of do a squared plus b squared equals c squared for any of those diagonal lines. So we already knew that, we had 5 and 12. And this is a special right triangle. I don't know if you learned any of those in middle school, but 5, 12 always goes with 13, but we'll kind of see that. So 25 plus 144 equals c squared. That's 169 equals c squared, and then you can square root that, and you get 13. So there are a couple special right triangles. 5, 12, 13 is one. 3, 4, 5 is one. Any multiples of 3, 4, and 5, so 6, 8, and 10. Right? If you see those, you can, if you memorize the patterns, you can, get the other numbers quickly. Okay. Anyways, that's going to be 13 right there. Right? So I did the 20. No, I did the 13. Then plus 6. Plus 10, plus another 6. And because of these little dashes, I know they're the same, so that guy's also plus 13. And you'll just add all of those up, right? So that's 33, 39, 49, 55, 68. If I messed that up, I'm sorry about that, but I think it's 68 units. And then that's it. Okay. So we'll just do a few examples from the homework. This will be our shortest video yet. So part A, they're giving us all parallelograms, and they're asking us on, part A, having technology problems again. Uh-oh. Let's see if we can get that. There we go. So they're just asking us for the perimeter, not the area, just the perimeter. So any lines that are horizontal or vertical, we can just count 1, 2, 3, 4, 5. This guy's also going to be 5. Opposite sides on parallelograms are equal to each other. And then to get this guy, we have to do an a squared plus b squared equals c squared. So that's 2 and that's 3. I'm going to put a c there. So 2 squared plus 3 squared equals c squared. That's 4 plus 9 equals c squared. 13 is c squared. Take the square root. I know it's going to be a number in between 3 and 4 because the square root of 9 is 3. And the square root of 16 is 4. So it's going to be somewhere in between 3 and 4. And when you type in your calculator, you get 3.6056. Remember, I said I want you to go out to 4 decimals until the final answer. So for perimeter, it would be 5, right? This 5, plus our c, 3.6056. Let's see, plus the next 5, and then plus this side will also be 3.6056. And so when we add those all up on a calculator, we will end up with 17.2. And it says round to the nearest hundredth, so you should get 17.21. And I could add in the word units. Be a little better. Okay, so that's it for part A. Very, very simple. Okay, anytime we have diagonal lines, a squared plus b squared equals c squared. Anytime we have horizontal, vertical, just count them. Next up, we have kind of a more composite shape, and some of these are composite shapes, but we're just finding the perimeter. So it's literally the same thing, but just with a different shape each time. So anything that's vertical, right, we can count 1, 2, 3. This looks like it's the same, 1, 2, 3, and then across 1, 2, 3, 4, 5, 6. Okay, and then anything that is diagonal, we're going to just turn it into a triangle. So that's 2, and that's 3. So a squared plus b squared equals c squared. I kind of picked these two because they both are 2 and 3, so we wouldn't have to do the math again. Right, so you can kind of see it's going to be the same. 4 plus 9, 13. Square root of 13 is what we just had. Right, and it was, now when I want it to go backwards, it won't go backwards. It was 3.6056. 3.6056. So both of those are going to be 3.6056. So our perimeter will be, if I kind of start here, 3.6056. I'm going to go this way. Plus 3, plus 6, plus 3, plus 3.6056. And we'll just add those all up on a calculator. And you should end up with 19.21 units. And remember, we are only finding the perimeter. We're not finding the area on part B. So nice and simple, that's it. And then part C, now they're asking us to find the area of our composite shapes. And so this is where you're just going to break it up into triangles and rectangles. There's a triangle, there's a triangle. If you want to go like that and have 2 rectangles, you can. If you notice, hey, you know what, I'm just going to make this a big rectangle, you can do that too. So this is area 1, area 2, and area 3. And if you notice, 1 and 3 are the same, then you don't have to really redo your work. So area 1, it's a triangle, half. The base of this triangle is 2, and the height is 2. So our area 1 is 2. Area 2, okay, is a rectangle. Base is 3. And the height counting is 1, 2, 3, 4, 5, 6. So we get 18. And area 3 is the same triangle, so it's 2 again, right? It's that same 2 from right there. So for our area overall, like our total area, is just adding them all up. And so we get 22 units squared. And like I said, this is probably the easiest lesson we have yet. I do want to point out one thing for the Carnegie. Okay, for the Carnegie, and when I say Carnegie, I really mean the Mathia, is on the Mathia, be careful. It sometimes gives you some of these. So some of these are given. It gave us the 45, it gave us the 180, gave us the 30, and it's asking us to find the unknown side. So you just kind of have to click it. If it's a straight line across, you can just count by subtracting the x's or the y's. So if it's horizontal, you can just subtract the x's. 20 minus 5 is 15. Okay. So it's asking us to do this whole like distance squared thing. You actually don't have to do that. If you just realized, hey, it's 20 minus 5, and you just put in 15 here, they're going to be fine with that. So don't waste your time on that. Just hit 15, hit enter a couple times. Okay, it's going to mark you right. Now for this one, you do have to do it. So 185 minus 20, you can use a calculator, do that in your head, is 165, right? And then 50 minus 35, you can do either order because remember, we're squaring it. So I can do 35 minus 15 and get negative 15, or technically if you put 15, you should still get that right. And then you have to use a calculator for this part. Okay, so anyways, I think I kind of skipped ahead on that by mistake, but you'll type that into a calculator, you get 165.68 for our distance, hit enter, and then just add these all up, and you'll get 435.68. So that's kind of how to do those. So again, you don't always have to use that distance formula. The other tricky thing on this, I don't have it pulled up right now, but one of the triangle problems, a couple of them, the endpoints are kind of weird. Just make sure you're looking at what triangle it's asking for, and it's based on what points they have. So sometimes on those triangles, they look a little funky because they're trying to give you like, at an angle, they like extend the height over. Just look at the endpoints to make sure which